Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of matrices and determinants. And if I talk about the question which is given to us here from this topic, the question tells us that if the minimum and the maximum values of the function where f is defined in the range of pi by 4 to pi by 2, which belongs to real numbers R, and that is defined by a function f of theta as determinant of minus sine square theta minus cos square theta 12 minus 1 minus sine square theta minus 1 minus cos square theta 10 1 1 minus 2. So we have been told if the minimum values of this function are small m and the maximum value is capital M respectively, then the ordered pair m comma m is equal to what? And if I talk about the answer choices that are given to us here, the options are 0 comma 2 root 2. The second answer choice given to us is minus 4 comma 0. Third answer choice is minus 4 comma 4, and the last answer choice given to us here is 0 comma 4. So we need to figure out which one of the answer choice is the correct answer for the ordered pair where small m is the minimum value and capital M is the maximum value. So let's figure out and let's try to find the determinant of that function f theta. So f theta, first of all, if I write it, it is given to us as minus sine square theta minus cos square theta 12 minus 1 minus sine square theta minus 1 minus cos square theta 10 1 1 minus 2. So this is f of theta given to us. We need to find the determinant of this entire thing. If you just find the determinant, it's fine, you will be able to calculate it, but it would become much more lengthy. So let's try to use some transformations and try to simplify our idea here. So what I can see here is this also has minus sine square theta, this also has minus sine square theta. So if I just add or if I just subtract the two columns, I can just get eliminated of this sine square theta from the second column. So I can change my second column as C2 is C2 minus C1. So that gives me f of theta as the first column remains same. We are just changing our second column. The third also remains same. The second column, if I see now, C2 minus C1, so minus 1 minus sine square theta minus of minus sine square theta. So minus 1 minus sine square theta plus sine square theta. So minus 1 minus cos square theta plus cos square theta. So minus 1 and 10 minus 12, which is minus 2. So we have this entire thing. Now, once we have this simplified in only the first column, we have sine square and cos square theta. So let's just expand the determinant. You get minus sine square theta. This becomes minus 1 into minus 2, which is 2, minus minus 2 into 1, which is minus 2. So 2 plus 2 plus 1, because minus of minus 1, you have got that as plus 1. This becomes minus 2 into minus cos square theta. So 2 cos square theta minus 12 into 1, which is 12. And the last one plus 1. Minus 2 into minus cos square theta. So 2 cos square theta minus 1 into minus of minus 1 into 12, so plus 12. So you have this thing. Now let's try to simplify this. You get minus 4 sine square theta plus 2 cos square theta minus 12, and the last, if you see, you got plus 1 into 2 cos square theta, so plus 2 cos square theta plus 12. Now once I have minus 12, once I have plus 12, that gets eliminated because it becomes 0. That gives you 4 cos square theta minus 4 sine square theta. 4 taken common, you have cos square theta minus sine square theta. And once you have that, you get that as expansion of cos 2 theta. So we already know that cos 2 theta, it is cos square theta minus sine square theta It is also 2 cos square theta minus 1. It is also 1 minus 2 sine square theta. So all of this are possible. So since I have cos square theta minus sine square theta, I'm just writing that as cos 2 theta. So you get the expansion of this entire determinant as 4 cos 2 theta. Now once you have that, the question tells us that you have to find the minimum and the maximum value for that function in this range where the values of theta goes from pi by 4 to pi by 2. So let's see. So we know theta belongs to pi by 4 to pi by 2. I need to find the minimum value and the maximum value of this function for cos 2 theta. So if I find first 2 theta, that belongs to, so I multiply these two angles by 2. So 2 into pi by 4, which is pi by 2, and 2 into pi by 2, which is pi. So you get the two theta values going from pi by 2 to pi. Now once you have that, you find the value of cos 2 theta. So cos 2 theta gives you cos of pi by 2, which is nothing but 0, and cos of pi, which is minus 1. So if I write it in the form of minimum and then maximum value, I get minimum minus 1 and cos pi by 2 is 0. So it goes from minus 1 to 0. Now I just need to multiply that entire thing with 4. So 4 cos 2 theta, that belongs to 4 times minus 1, which is minus 4, 4 times 0, which is 0. So you get that in the range from minus 4 to 0. So you get your ordered pair small m comma capital M in the interval of minus 4 to 0. And if you see the answer choice that matches here with the question, it is option B. So B becomes the correct answer for the question given to us here. We get the minimum value as minus 4 and we get the maximum value here as 0. So your answer becomes option B. So what we did was with just a common column transformation, I just got eliminated of theta from the second column and then expanded the determinant. I got that simplified as 4 cos 2 theta. Then from the intervals of theta given from pi by 4 to pi by 2, I found the values of 4 cos 2 theta that gave me minimum and maximum values as minus 4 and 0. And that, if you see, matches with option B. I hope you have understood how to solve this type of questions on matrices and the determinant part. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing every day, please do like the videos as well and do subscribe to my channel and share these videos with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. See you again tomorrow with one other video. Thank you.